are several ways we can make computer programs execute the code that we want to run. Remember, all programming is about handling data and changing it from one thing into another, or storing it in a particular place. And there are various ways we can do it. And sometimes these are called the styles of programming, sometimes they're called the families of programming, sometimes they're called the types of programming, and sometimes they're called the paradigms of programming. And we deal with principally three of them. There are others, but there are three that we deal with in the main schools of programming that are used. The first one is event-driven. That's where in our program, one thing responds to an event that's raised by the user. For example, a click of a button, or it responds to something that the system itself does after forming some sort of process to control something. For example, a save. The event that's raised might be a notification back to the user saying this has been saved. The second type of programming that's used is called procedural programming, and that's where the things that the program is asked to do is split into mini programs of their own sort of size and shape, which only do one thing, and therefore we can call those things to be used when they're needed. So what do? They work on objects, and that leads us to object-oriented programming. And object-oriented programming is a process of taking any situation, any scenario, any problem we have to solve, and splitting it up into things that can be done as a single unit. And we call these entities. Now, the program that we're going to build has entities that I've kind of identified as a starting point. And these are known as the classes that we will implement. There's a person, an observation, a summary, a person DB, an observation DB, and an import data class. And what are these for? Well, the person class will hold the things we want to deal with as data in a person. For example, their forename, their surname, their address, the town, and so forth. These are the things that relate to one individual that we can treat at a time. An observation is the things that this person has looked at and we want to record. The person DB class enables us to use the person and manipulate it when we're storing it and retrieving it. So they have separate jobs. The person holds the data and the person DB in this case does the job of retrieving and storing. Similarly with observation DB. The observation is the data that we want to store, and the observation DB class deals with the storing of it and the retrieving of it. Now, summary is going to be a data class that's going to be allowing us to manipulate the stored observations in a particular way and present them back to the user in a certain style. The import data class sitting off to the left here is a class that's used to manipulate text in a text file, and that's its only job, is to return the text from a text file as a thing that we call a data table so that we can go through those lines of text and deal with the data they contain. So you'll see in this diagram that we've got, for example, in the person class. Look at that one on the right-hand side at the top. Each class that we're talking about here is represented in what we're calling here a UML diagram, a Unified Modeling Language diagram. And the class has three aspects. Its name, which is person, and this is mandatory. All classes must have a name. And then in the middle box, we're going to describe the data that the person is going to have. The first one will be forename. It'll be of type string, and so forth. In person DB, we won't do any data in that middle band, but in the bottom band, we'll put the methods. Those are the method members, as opposed to the data members, and opposed to the name member. So each class has three potential members that we can describe. Some classes will have both data and methods, but often we'll separate the processes between the data and the method so that the class deals with just one aspect of the entity. Just about everything we do in class programming, or everything we do in programming, in fact, is represented by a class. Here in our application, we've got to this point where we've created three forms. These are classes, and they inherit from the class form, And we'll use these objects, these instances of a form, to control the way they look and the data that they will hold and the code that will run when we need to make them do things. So in our code files, we have C#. That's the name of the style of language that we're going to use. It's one of the C-based languages. And all forms in Visual C# have a code behind which describes how the form itself is managed for display and eventual for killing when it's no longer needed. But classes are just a way of describing things which can do one thing and one thing only. So what's the advantage? Well, the advantage is the splitting of things into their own separate parts. And it means that if I make a change to one of our classes, it doesn't affect anything else apart from those classes then presenting new information or less information depending on how the changes have been made. So we've got that reusability, which means that if I've used a person class once in my programming, it's very likely that I'll be able to implement it again as a person when I do a different program. And perhaps the biggest of the advantages of object-oriented programming is what we call inheritance. I can create a person class and give it forename, surname, and date of birth, for example. And then I can create a subclass called a child class, which might be a student or a teacher. And then the child class would just have the special information that relates to a student or a teacher. And another advantage that we've got is that in the data we store and the methods that we use what's called encapsulation. And encapsulation means that I can hide things so that they cannot be seen by other classes in the program. And that uses scope in order to make sure that if I've got something in person that I don't want any other class to be able to access and change, I will encapsulate it inside a private membership, and that means it can't be touched by anything else. There's a third fundamental pillar called polymorphism, which means that you can use classes in lots of different ways. But that's for a bigger discussion in more detail when you're actually studying OOP programming as a science. So as I say, in our program that we're going to create, we have a starting point of these, and I've not put any data members or method members in yet, but we'll monitor this and you'll be asked to create a diagram like this as part of your planning process. So we'll make that diagram to help you understand how the diagram can be shaped when it's needed to be used in the assignment scenario. So that's an introduction to object-oriented programming. It's one of the 3 paradigm styles or types of programming, and it's where we take all of the problem and split it up into objects which can do one thing. These objects are called entities, and they will always have a name, and sometimes they'll have data members, and sometimes they will have method members. So that's just the vocabulary that we're going to use when we're talking about classes. Now, as we create our classes, we'll implement them, and you'll hear me use that vocabulary, and it's important that you try to remember how those words are used, because they're really good words to use in an assignment.